Okay, problem 2 is the integral test. Okay, let's try. So, first problem, we want to figure out whether this series is convergent or divergent. So the integral test idea is very straightforward. For a sequence at point 1, at point 2, at point 3, you have like certain values, right? So the value is the length of this, the value is the length of this, the value is the length of this. And the summation, right? The summation, the series, it's a summation of all these lengths, right? It's a summation of all these lengths. It's a summation of all these lengths together, right? And is it a finite number or is it infinite? So this is a series. But what about the integration, right? We still have its corresponding fitting function. The integration calculates the whole area under the curve, right? The integration fx is ax corresponding function. The integration calculates the area of this whole part, right? So if this integration is convergent, then this is convergent. If the integration is divergent, then this is divergent. Okay. So that's what we call the integral test. But before we do the integral test, there are several conditions this sequence must satisfy. First, this sequence must be positive, right? An must be positive. Okay, An must be positive. And then An is continuous. And then the corresponding function is continuous. And the third condition is this function must be decreasing. Okay, but for condition 2 and condition 3, it doesn't require the function to be continuous or decreasing from 1 to infinity. It doesn't require, right? It only requires the function to be continuous and decreasing from a certain value, let's call it t, right? From t to positive infinity. This t could be 1, it could be 2, it could be 3, it could be any finite number, right? It could be 1000, it's fine. Just any finite number, as long as you can find this t, right, such that the function is continuous from this t to infinity and it's also decreasing from this t to infinity, it is satisfied. Okay, so let's check this function first. First, 3n minus 1 to the power of 4, right? When n is greater than 1, right, this part is always positive, right? So the ratio, the fraction is overall positive. So the first condition is satisfied. Okay. For n greater than 1. Okay. Second condition, the corresponding fitting function, right? This function is continuous when x is greater or equal to 1, right? When x is greater or equal to 1. And this function is a decreasing. For decreasing, right, a decreasing function, the derivative is smaller than 0. Right? For an increasing function, the derivative is greater than 0. So we just have to figure out its derivative. The derivative is, right, it's 3x minus 1 to the power of negative 4's derivative. It's negative 4, 3x minus 1 to the power of negative 5 times 3. Right. So it's negative 12 times 1 over 3x minus 1 to the power of 5. And this is smaller than 0 when x is greater or equal to 1. Right? So this f prime x, is smaller than 0 when x is greater than 1, which means your fx is decreasing when x is from positive 1 to from 1 to positive infinity. Okay. So now the integral test we can use, right? This series is convergent if and only if, right? This series is convergent if and only if, so I just write as if, right? If and only if. Okay. Let me just write if and only if. If and only if this integration, right, from 1 to infinity. This 1 is from here. Okay, it's from here. From 1 to infinity, 1 over 3x minus 1 to the power 4 dx is convergent. Okay, then this part, you just have to do the integration. This part, the integration is, it's actually 3x minus 1 to the power of negative 3, right, times negative 1 over 9 from 1 to infinity. Okay, you can see it's a limit t approaching infinity, negative 1 over 9, like 3t minus 1 to the power of negative 3, right, plus 1 over 9, 3 times 1 minus 1 to the power of negative 3. Okay, so this part, it's because it's to the power of negative 3, so this part overall it's 0, right? So it's 1 over 9, right, 2 to the power of negative 3. So it's 1 over 72. Okay. Since this is a this is a finite real number, which means so this integration is convergent. Right, which means the series is convergent. The series is convergent. Okay. To B, it's very similar. Okay, 2B is very similar. Again, you have to check first, is it positive? Right, first you have to check, is this positive? Yes, right, because this is positive, the top is positive, the bottom is positive when x is greater or equal to 2, right? The second part, you have to check the fitting function, is it continuous? Okay, is it continuous? And the answer is yes. Right, the answer is yes, because it's the combination of some polynomials, so it is continuous. And the last part is fx, right, decreasing, so you have to figure out its derivative. It is x to the power 4 plus 4 squared, right? This part's derivative, 3x squared times x to the power 4 plus 4 minus x cubed times this part's derivative, right? 4x cubed. Okay, so this is, you combine these two parts, it is minus x to the power of 6 plus 12x squared. Okay, and it is x squared over x to the power of 4 plus 4 squared times negative, right, 12 minus x to the power 4. So when x is greater or equal to 2, when x is greater or equal to 2, right, this part is greater or equal to 16, so this difference is smaller than 0, right? This part is square, it's always positive. So it is smaller or equal to 0 when x is greater or equal to 2. Right. So the function is decreasing when x is greater or equal to 2. Okay, so continuous, great positive, and decreasing, so we can use the integral test. So the integral test, we just have to calculate from 2 to infinity. Okay, again, 2 is from here. If here is 3, it is 3. Okay. X cubed over x to the power 4 plus 4. Right, here it's obvious you can use a substitution method. U is x to the power 4 plus 4. Then du over dx is 4x to the power 3. Then dx times x to the power 3. Right, it is du over 4. So here it is the integration. Okay, so now it's 2 to the power 4 plus 4, because here is x is 2, u is this, right, to the power of infinity. Then here x cubed times dx equals 1 over 4 du, right, 1 over this, which is this, 1 over u times 1 over 4 du. Okay, so it is the integration of u is ln absolute value of u, right, 1 over 4 from, okay, here it's 20, right, from 20 to positive infinity. Okay, so it is limit t is approaching infinity, 1 over 4 ln, right, ln t minus, here you sub in 20 minus 1 over 4 ln 20. Okay, so this part obviously it is divergent, right? So overall the result is divergent. Okay, it is positive infinity, so it's divergent. The integration is divergent, which means series is divergent, right? So that the series is divergent. Okay, the series is divergent. Okay. 2c. Function is, right, the series is n times e to the power of negative n squared. So again, first thing, this is positive, right? E to the power of something is positive. This part is positive, this is positive. So overall it's positive when n is greater or equal to 1. And the corresponding function, the fitting function x e to the power of negative x squared, it's continuous, right? Again, it's a combination of basic functions. It's continuous. And is it decreasing? We can calculate its derivative. It is this part's derivative, which is 1 times this, plus this times this part's derivative, right, which is negative 2x times e to the power of negative x squared. So it's 1 minus 2x squared e to the power of negative x squared, right? As long as this part is smaller than 0, this part is always greater than 0. So, right, so it is smaller than 0 when x is greater than 1, okay? So the function is decreasing on the range 1 to infinity. Okay. So you can calculate the fitting function's integration from 1 to infinity x e to the power of negative x squared dx. So again, you can use a substitution method. You let u equals x squared, right? Then du over dx is 2x. So x times dx is half u du, right? So here u is x squared, so u is x squared. Here x times dx is half u, half du, e to the power of negative u. Okay. So it is e to the power of negative u, negative half, right, from 1 to infinity. So it's the limit of t is approaching infinity, negative half e to the power of negative t, right, plus half e to the power of negative 1. So when t is approaching infinity, this is 0. So, sorry, this is negative infinity, then overall this is 0, right? So it is half, right? It is half e to the power of negative 1. So this function is convergent. Right? So the corresponding sequence is convergent. Right? This series is convergent. Okay.